Welcome friends. Today I shall discuss about the first law of thermodynamics. Now, what is the first law of thermodynamics? Let us explain. The first law of thermodynamics is basically the energy conservation law. Energy conservation law. This law basically states that the energy cannot be created nor be destroyed. It can only be transformed from one form to another, and the total energy in the universe remains constant. This is simply the energy conservation law. Now, we know that whenever heat energy is converted into work or work is converted into heat, the amount of work done is proportional to heat. That is, W is proportional to H, from which we can write W equal to JH. What is J? J is nothing but the mechanical equivalent of heat. Mechanical equivalent of heat. From this, we can easily give a definition of J. So what is J? J is W by H. This means if H equals to 1, then W equal to J. That is, mechanical equivalent of heat is defined as the amount of work done to produce unit amount of heat, right? This is the work energy conversion. Let us try to find out the first law of thermodynamics in another form. Now, suppose we consider a system where we supply Q amount of heat. Q amount of heat. So, if we supply some amount of heat to a system, one part of it increases the internal energy of the system and rest performs the amount of work. That means if U1 and U2 are the initial and final internal energies of the system, then this law can be written as Q equals to U2 minus U1 plus W. U1 is the initial internal energy of the system, U2 is the final internal energy of the system, and W is the amount of work done. So this is the basically mathematical form of first law of thermodynamics. Q equals to U2 minus U1 plus W. This term represents the change in internal energy and this term represents the work done by the system. So this is the mathematical form of first law. Mathematical form of first law. Now let us try to find out this meaning in terms of calculus. Now suppose instead of Q amount of heat, we give dq amount of heat to a system, and if du is the change in internal energy and dw is the amount of work done, then dq equals to du plus dw. the differential form of first law of thermodynamics can be written in this way. Now let us calculate the value of dW in a more general way. Suppose we consider a system where pressure remains constant but volume increases. Okay, suppose we consider a system where pressure remains constant but volume increases from V1 to V2. Then the amount of work done can be written in this way: dW equals to P into V2 minus V1, pressure multiplied by change in volume. So this can be P dV. So equation 2 becomes dq equals to du plus P dV. So this is the differential form of first law of thermodynamics. Equation 3 is called the differential form of first law. Okay, thank you.